Introducing Portraits and Ideas. I'm Erlen Gal presenting interviews to inspire and perhaps unveil something new in the realm of ideas. Today I would like to introduce to you Professor Zhiping Lai, who is Professor of Chemical Engineering at KAUST. Professor Lai, why did you decide to come to KAUST?
Because cost provided me a big opportunities, and I can come here to do the research what I want, and they provide me quite a good findings, and also the most important thing I think is I see there are a lot of very good people here, so I can work together with them and can collaborate with them. So I believe that it will be very helpful for my academic career.
How would KAUST differ from other universities that might offer similar things? I mean, what distinguishes KAUST from places that you might have gotten other offers from?
Okay, I think KAUST from the very beginning is very oriented because they get people from all over the world, and they have centers, and so these centers they already have a keen research objectives.
Mm-hmm.
So they get peoples and almost the best people from all over the world in this field.
Mm-hmm.
And also it's the facilities. So here.
You mean lab facilities?
Yes,
right.
Lab facilities.
Uh-huh.
It's world class facility. I would say that that's the almost the best facility I have seen in the world.
Mm-hmm.
So I think this it's very different from other universities. Yeah. So from other universities, you sometimes you work alone, and you need found for example the research collaborations by yourself. Yeah, but
Mm-hmm.
here it's like the university help you to find all the people, all
Mm-hmm.
the best people from the world.
Yeah. What I'm hearing is that you have a model of that promotes collaboration,
Right.
so that you don't have to work in isolation, and
Right.
and you can really be a part of an interdisciplinary team.
Correct.
Yeah.
Yes. Right. Yeah.
So that becomes very attractive
Yes.
in terms of productivity and new ideas and so on.
Right. I think if you have a good team, then definitely it will be productive,
Mm-hmm.
and also definitely it will pop up a lot of ideas.
Correct.
Yeah. And particularly is that it's create a very good environment that you can realize your idea very quickly.
Mm-hmm.
That's what I think. Yeah.
Right.
Otherwise, you have a good idea, but you still have to find the right collaborators
Mm-hmm.
to help you to realize your idea. That takes time.
Mm-hmm.
But actually, the ideal usually many people have.
That's
the
right.
question is how fast you can realize it.
That's right.
Yeah, that's the most important thing.
And you'll have the laboratory resources
Right.
to augment
Right.
that collaborative team out there
Right.
to realize these ideas.
Right.
Yes. Yes.
Right.
What advice would you give to the youth in Saudi Arabia to promote their interests in pursuing science and technology careers?
First, I think to get the best people in the world, and currently, I think the faculties recruited so far are very good. So I think KAUST should keep this high standard, and because only the best, the faculties will attract, even good people to come to KAUST in the future, and also good students, and also it will generate good results. So that's the most important thing.
Now, I'm speaking more generally as a message to students who may not particularly end up coming to Kaus in the future, but they are looking at what kind of career they might pursue, and they are looking at possibilities. Why would you suggest to any youth, among the thousands of youth in Saudi Arabia, why would you suggest to them science?
You mean, okay, so, well, I would say science is it's a very, it's very broad, like, it's a very broad word, I would say. It's like this. We need to specify it. Okay, for example, let's say if I'm a student, and when I choose, if I want to choose the university for my PhD studies, first of all, I will see that what is the capability of this university, right? Can I do a good research over there, right? And so usually to see those things, that's the faculty, the people over there is very important. If you see, okay, say if you know, the best people in the field are in that university, then you definitely believe that you will have a good training over there. You will achieve.
Okay. Now that's taken it to the step where once a student decides, then they say, well, where do I go to really become the best? Now that's a good point, but I want to go back a step before that, to the point where a student is thinking about a career, and they say, well, maybe I will become a fireman, or maybe I will become a administrator, maybe I'll become an attorney. Why would you suggest them science is perhaps a better choice? That's the question.
Oh, okay. Well, I think that's actually sometimes it's a personal choice.
Okay, sure. It's a personal choice, but why did you choose, for example? I mean, obviously you went through a thought process when you decided on a career. Why did you choose science? Maybe that would give a youth that would be listening to this an idea about why they might choose science.
Okay. First of all, science is useful to the human being, right? And you can make contributions to the entire world. Okay. You can, for example, make contribution to the country, and if you are able to invent something, if you are able to understand something, okay, and then you make contributions to the society.
So you see that science as a method of getting the possibility of making a bigger contribution than in other professions.
Yes. Well, other professions also will contribute to the society. As I said, it will depends. Depends your personal interest. Yeah. Somebody, for example, they like being a singer, okay, and he can make a big contribution to the society also.
As
a singer, for example.
In music.
Music,
right.
Or a lawyer. He can also make a equally contribution to the society. That's not a problem. But some people may just like science because he wants to understand the nature. Yeah, he wants to understand nature. But sometimes some people may like, okay, I want to deal with peoples.
Right.
So I like to interact with peoples.
Sure.
And some students they say, okay, because through their high school studies they are very interested in nature. They want to understand a lot of things. For example, happens in the nature. So now
you're mentioning interacting with people. You can have a science career and interact with people considerably, as you would say, being an attorney, for example, right?
Well, I have another actual suggestion for cost, particularly. I think if we are able to, let's say, to open the campus to the entire society, say several times a year, and we can invite normal people to visit the campus,
Yeah.
or we can give open seminars. For example, we can invite, very good people,
Sure.
famous people, give a topic, not specifically that very deep in science. They
Sure.
can just the common topics
Right.
like,
For the general audience.
Right,
For the general
right, general audience.
That's
We
right.
can, let's say, we have a very good, facility in cost. We can invite local peoples,
Sure.
right, to attend this kind of
Community seminars.
Right, right.
Yeah, on science topics.
Right. To stimulate their interest,
Sure.
particularly young
Sure.
people's.
That's right.
Young people's interest in science.
That's right.
Right. I think that would be.
So I think that's an excellent suggestion that we can look at students who are in school, for
Right.
example, and invite them to CAUS.
Right. High school
and-
students, we can invite them to visit the
That's right.
campus, and show them the facilities, Yeah.
This could be very pivotal for them in their career because many great scientists, they always point to some experience,
Right.
some field trip that they took
Yeah.
as a student
Right.
that really stimulated their interest to
Right.
become scientists.
Right. That's
So CAUS can be very proactive
right.
to do that. And I think that's one of the objectives of this discussion that we're having now is
Right.
for students who will hear your comments to get ideas on how they might succeed and have an interest in science.
Right. Right.
How did you reach the position you are in today in your profession? Please outline your career and explain the milestones of your educational advancement to the PhD and after the PhD.
Okay.
And speak up a little louder.
Okay. I didn't get your accent. I didn't get your question.
So the question is, give us a outline of your career.
Okay.
You know,
Okay.
starting from grade school and on up, and you got degrees along the way, and you were stimulated along the way. Obviously, to reach the high level of science as you are presently have reached, there were milestones along the way of getting a degree, of moving from one level to the next. So, give us the schools that you attended and the kind of degrees that you acquired.
Okay. First of all, I would say that when I was very young and I'm very interested in science. Okay, I'm very interested in to understand the those things happens for example every day, and happen that I can study very well. Okay, get good marks in my high school, and which actually enabled me to go to a very good university in China. And so after I finished my bachelor degrees in Tsinghua University, China, and then at that time I took the chemical engineer, and I found that it is actually it's a very interesting subject, and but it's
Yeah, take your time. Take your
Okay.
time. Don't.
yeah.
You found chemical engineering to be quite interesting, so you decided to go and get a higher degree.
Right. So I went to US and I get my PhD degree in University of Massachusetts. Yeah, and over there actually I chose my research area, which is membrane research, and because first I was thinking to my advisor, Michael Sapathis. He's actually a very good advisor. And,
his name again?
Yeah, Michael Sapathis. Yeah, and on his supervision, for the first time I feel that I can actually, make a contributions to the science. I can, for example, understand what somebody else cannot understand. Okay, I can make a, use this understanding. I can make a good membranes. Yeah, and so I'm confident at that time. Before I just study, so I can, I can get good marks. But only, in the U.S. Massachusetts, I was able that I found that I can also use what I have learned to make contributions to the society, and particularly found that the membranes we made have great potentials to, for example, we can use membranes to separate a lot of things. For example, water decellulation and separate hydrocarbon mixtures, and also can use to filter wastewaters. Yeah, all these things are challenge issues in the current world. Okay, and I realized that the technologies I learned and also I developed can help to solve these kind of questions, these problems. So it actually makes me very excited. So that means I can. It's not just a waste of money, waste of time. I can do something. Yeah.
So along your career studying, it was a bit abstract, and then all of a sudden you got the realization that this can be applied to major problems, and we can make a huge contribution to the world.
Right.
And that obviously was a big motivating force to continue.
Right, that's true. Yeah.
Why did you decide to pursue and get a PhD? Was that something you came up with on your own initiative, or did someone give you that advice to pursue a PhD?
Well, when I was very young, I had a dream that I want to be a scientist.
Sure.
Yeah. So obviously, when I finished my undergraduate degrees, I found that what I have learned is not enough, because you cannot work independently. So, if you want to work independently, you have to get a PhD degree, and also at that time, I think the American universities, they give me a very good chance, so I can go there to get my PhD degree.
So would you advise a young scientist who might be interested in a career in science to get the PhD as the goal in their educational process?
I would say that's what again, it's a personal choice. Yeah. So if you have a strong interest to be a scientist, particularly you want to become a independent investigators. You wanted to make contributions, and then you have to take a PhD degree, because what you have learned in the undergraduate, it's not good. It's not enough. And I wouldn't say that to get a PhD degree is the only way that you can make a great contribution to the society. But if you want make a great contributions to science, then you have to take a PhD.
That level of preparation is almost essential, in a sense.
True. Yeah. Because only in the PhD studies it will train you how to how to investigate scientific problems independently.
What, in your experience as a student and as a scientist, what is the relative advantage of hard work versus high levels of intelligence to accomplish your goals?
I think both are very important. Okay. First of all, I think the most important thing is the supervisor, is the group. Okay, the research group. Okay, if this research group is very strong, okay, and then it will give you a great opportunities. Okay, and otherwise, if you for example choose a wrong direction, or if you stay in a group, okay, which have, it's not for example the either the research facility is not that great, or the group, okay, is not that productive. Okay, then no matter how hard you work, okay, maybe it's very difficult for you, okay, to come up with a great idea, okay, or make a great achievement, because from the starting point, okay, you already lose. Okay, so that's why I think that's why we came to KAUST, because here we have a very good facility. Also, we have good people here. So, so that's the first choice. Is the first thing you need to consider. You need to think about it. Okay, and then once you join a good team, okay, you work on the right, okay, topic. Okay, you have all the necessary conditions. Okay, then of course you also need to work hard. Yeah. And because the usually, if you want to get a great contributions, which means usually the topic is a challenge, is very difficult, and often you have to work very hard and to solve it. Yeah. So I would say that the most important thing is the research group. Is the reputation.
I hear that message very strongly, that you need to think about the team,
right,
and the quality of the team that
right,
you belong to.
Right, that's true. Yeah.
Sure. And then you start looking at those other factors. So
right.
so what about a student who is studying?
Yeah.
And they're going through their various courses, say to get a degree, whether it's a bachelor's or a master's or a PhD. Now they may belong to a research team at a higher level, say at the PhD, but in the earlier levels, a lot of the study is largely being alone, and then preparing yourself for an exam that would be given.
Right.
How would you value hard work versus high levels of intelligence in being successful at that level?
Okay.
Before you end up joining a team, you understand?
Yes. Well, hard work is essential, to do everything. If you want to achieve anything, you want to get success, and you have to work hard. Yeah, that's there's no shortcut. There's not, and but just working hard, it doesn't mean that you will get success. You also need to open your mind. Okay, you need to think about it. Okay, what it's what you are going to do in the future. Yeah. And sometimes you need okay, it's like because now it's also the idea of KAUST, that we need a interdisciplinary research. Okay, so you need if you just focus on a small field, no matter how hard you're working, you probably it's still difficult to success, to get success. But if you have an open mind, okay, if you pay attention to different disciplines, okay, and then you will understand what is your capability, yeah. So which areas most it's you can fit, better, and then if you also if you work hard, then you can then that would be then that's the only way you can get success.
Right.
Yeah.
In other words, what I'm hearing is that hard work is absolutely essential.
Right.
If you have the intelligence to add to that, then you have some additional advantage.
Right.
But we need to start out on a platform of hard work
Right.
as the basic criteria for success, if
Right.
you will.
Right.
Yeah.
Right.
So I think that's a good message, because maybe a student might feel that they are not as capable as, say, the next student,
Right.
but they can actually narrow the gap by working hard, and pursuing it a little bit more relentlessly, in their study efforts and so forth. So that can give a lot of encouragement to quote students who might think of themselves as somewhat weak. When did you decide to become a scientist researcher? Was there a point in your career when you said, this is for me, I'm going to continue along this track?
Okay, I think it's after my undergraduate studies. Yeah, at that time I feel that I'm interested in doing research.
Mm-hmm.
So I want to if I want to continue, if I want to stay in the academia, I have to get a PhD studies.
Sure.
Yeah, but the time to actually figure out which areas I want to work with is during my PhD studies.
Mm-hmm.
Yeah, and during my PhD studies, I found that I'm capable to do research.
Mm-hmm.
So I can stay on the academia area.
What childhood stimulus did you have, when you were much younger,
Okay.
that made you, for example, you applied to the leading science and technology university in China, Tsinghua University,
Yes.
and you got in.
Yeah.
Obviously, when you look at all of the applicants in China, there must have been a large number of applicants,
Right.
and you made the cut, so to speak.
Right.
So you must have had some motivation early on to be competitive in that applicant pool,
Okay. Well, I think first of all, is the curiosity. Yeah, because I'm curious about everything.
Sure.
Yeah. So in my high school, I have read a lot of books considered which is it's not necessary, or sometimes my parents or other people may think that it's a waste of time. But I have read a lot of books, scientific books.
You went to the library?
Yeah, I went to library.
Mm-hmm.
Yeah, at that time actually we the condition is it's not that good, and our library actually has very few books.
Mm-hmm.
But also I found that at that time not many people actually are interested in reading extra books
Outside of their normal classes in
so,
school. Yeah.
So I found that by reading those extra books, actually I gained more technologies.
General knowledge.
Yeah, than other persons.
Mm-hmm.
Yeah. For example, I remember in a competition, it's like a scientific competitions. I can answer questions which is typical. Those questions are at that time I'm a secondary.
Mm-hmm.
School
in secondary school.
Right. But those questions actually, they're supposed to ask for the high school, the high grade,
Higher level.
high level students. Sure. But they cannot answer, but I can answer. So I feel that this time I spend it's worth.
It's paying off for you.
It's paying off.
The reading actually has really become a big benefit for you.
Right.
Yeah.
And particularly you will feel very happy if you can answer a question which
Sure.
others cannot answer.
So you were able to win some of those competitions.
Right,
Yeah,
right.
that's right.
So,
Early
yeah,
on.
I think it also happens when during my later stage studies.
Mm-hmm.
Yeah, if you are able to achieve something,
Sure.
which somebody else have, it's very difficult. It's a quite difficult questions.
Sure.
Then it will actually stimulate your interest
Mm-hmm.
to.
How did you prepare? Obviously, you had to take some tough exams to get admitted to Tsinghua University. How did you prepare for those exams? What was your strategy?
Okay, my strategy is of course we have a lot of subjects. I'm not good on all subjects, and I'm good on certain subjects, particularly in certain like mathematics, like physics and chemistry. But I'm not good in English, in language. I'm not good in other subjects. Okay, and I found that if the subject you are very interested, for example, I'm very interested in chemistry.
Mm-hmm.
I spend very little time on this subject to get good marks.
Because you know it already.
Yeah, because it's I don't know why, but if you are interested in this subject, you will find that it's very easy to remember everything. You needn't remember. It's just like you can remember it.
Right.
Just
comes naturally.
Yeah, it comes naturally.
Yeah,
Right.
yeah.
Right. But of course, you have to because at that time we have to get Tsinghua University. We have to study well for all the subjects.
Okay.
So my strategy is to spend more time on that subject.
The subject that you didn't know as much about. Right. That's right.
So you have to other things that is you have to work hard. You have to study very hard.
Mm-hmm.
Yeah, because you always have a week, so you have to spend more time.
Mm-hmm.
Yeah, to improve your.
So how long did it take you to prepare for those exams? I mean, how many years did you spend studying, and about how many hours per day did you have to work on preparation?
Okay, I would say I will spend probably like 1 to 2 hours more than normal students.
Extra.
Extra, yeah.
So what would be the total?
Uh,
What would be the total number of hours that you spent studying? This is after school.
After school, okay. I would say maybe 10 hours a day.
After school?
No, not after school.
But
Including
school.
Right.
Okay.
After school, about 2 hours.
2 hours, okay.
Yeah.
And that was in preparation for the exams, the national exams?
Right.
Uh-huh.
Right.
And so how many years were you studying or preparing? You actually say, I'm really working for this.
No, we are just
video.
actually, we just follow the regular, high school studies.
Okay.
Yeah. Not extra.
So you didn't have to take a special exam
No.
for college admission?
No.
So how did they determine that you got admitted to Tsinghua?
We have the, we call it's a national, entrance exam.
Yes, that's what I mean.
Everybody will take.
Sure.
Yeah.
That's the exam I'm talking about.
Right.
How long did you study for that? How long did you prepare?
We didn't prepare it specifically. We just follow the normal
Courses.
the schedules. Yeah. For example, after we finish the high school, we need to take this exam.
Sure.
Yeah. And then if your performance good, then you can go to a good university.
So how long is the exam? How many days?
Well, it takes 3 days.
3 days.
Yeah, it takes 3 days.
Like
Yeah.
8 hours each day.
3 days. Let me see. Yeah, we have at that time we have 7 subjects.
Sure.
Yeah. So so every day you need to take
Two subjects.
two subjects.
Mhm.
Yeah. One is in the morning, the other one is in the afternoon. I can't remember what is the time, like the exam time.
Sure.
But I remember it's 7 subjects,
Sure.
and it takes 3 days to finish. Yeah.
So were you nervous?
Yes, of course, it's very nervous. Yeah, and because this is very important.
Sure.
At that time, we don't have second chance.
Were you surprised when you got a letter from Tsinghua saying that you are admitted?
Well, actually, not very surprised because I during my high school actually I'm always the top students.
Is that right?
Yeah.
In top student in the school, or and then what about your province?
My province is Hunan province.
Hunan.
Yeah.
Uh-huh.
And okay, that one is a big the population is more than 50 million.
Mm-hmm.
I think I don't know overall what is my rank.
Right.
Yeah, but I'm the best in my county. We have
One county in
yeah,
Hunan province.
Right.
Yeah, that's
so,
right.
for example, like the population of each county about 400,000.
400,000.
Yeah,
Uh-huh.
so 500,000 something like
Sure,
this.
sure.
Yeah. So.
So when you got your letter, that must have made your family, your parents happy.
Yeah, of course. Yeah, because.
So you left to go to Beijing for the first time, right?
Yeah. That's first time I actually leave my village.
Is that right?
Yeah.
So you're kind of a village hero.
Yeah, kind of. Yeah.
They certainly celebrated your
yes.
accomplishment.
Yes.
So how many people from your county were able to go to Tsinghua or Beijing University?
Usually one per year.
No more than one.
Yeah,
really?
Usually one per year.
So that tells you how tough it is.
Yeah, it is quite tough.
Quite tough.
Yeah.
Did you find it very difficult when you got to Tsinghua University to the studies, the level of the studies? Was it difficult for you to adjust to?
Not really.
Mm-hmm.
Not really.
Mm-hmm.
Yeah, and of course in Tsinghua University because the students are all the best
in the
country.
Yeah.
So I'm not I'm
not the best anymore.
I'm not the best anymore. Yeah. But well, I think that also I found that I'm also not that bad. For example,
right. You're doing pretty good.
Yeah. So compared to the number one, not much difference.
Sure.
Yeah,
Sure.
Yeah, we are. I would say in the same level. Actually, all my classmates did very well.
Right. So once you get to that level, everybody's good.
Yeah.
That's right.
Yeah.
Did you find that you had to increase the number of hours after school to study at Tsinghua?
No, it's just spend a normal time.
So when you finished, how many hours after classes did you study in Tsinghua?
Okay, we have a normal schedule actually in Tsinghua University, and for example, we have in the morning we have lectures.
Sure.
And sometimes in the afternoon we also have lectures, but I think most of the afternoon is empty. It's for the students to study independently.
Sure.
And also in the evening we also usually spend 2 hours in the lab, in the library.
In the evening also?
Yes.
Till what time?
I think it usually starts from 7 to end at 9.
So when do they give you time to go to the library and study your other classes?
No, this actually if you don't have lectures, right? It's actually your time. It's you can use it.
You can either go to the lab or you can go to the library.
You can decide
what you want to do.
Right. It's free actually.
So how much time did you spend going to the library? Say after you finish your lab and so on.
Okay. I'll stay every day maybe 2 hours a day and 2 hours.
And then you go to bed by midnight?
Yeah, after 9 o'clock usually. Yeah.
9 o'clock?
Yeah.
You went to bed that early?
Right. Okay. 9:30 something like this.
Really?
Because.
What time would you wake up?
I think it's 6:30.
A.M.
Yeah, 6:30 a.m.
So you didn't really have to go after midnight so much for studying.
No.
So that means that you understood the material enough that you didn't you didn't have to put all these extra hours in, so to speak.
Right.
Yeah.
I think that the important thing in the undergraduate studies it's not just study. It's not just course studies.
So what else is involved?
Also, you need now you need you need to develop the skills for your future careers, for example. Okay. For example, let's say now you need to consider your future. Yeah. Either you want to go to industry or you want to go to academia. Right? And so you need also I think it's good to actually you develop other like social skills.
Sure.
And or even or other skills, personal skills.
Sure.
Yeah, to prepare for your future career.
Did you obviously worked on those areas to
Right.
build those skills?
Right.
What are the key skills that you think one needs to have in addition to the social skills and so on? What are the skills?
I think the most important skill is you have to learn how to work independent. Yeah. So now you have to learn how to solve the problems by yourself.
Right.
Yeah, not by somebody else. Yeah, because in high school studies, everything is taught by the teacher. Yeah, and all the answers are correct. Yeah, all the questions have an answer, and all the answers are correct. But now in undergraduate, start from undergraduate student, you will face problems which has no answer. You have to solve it by yourself.
Difficult ones.
Yeah. Also, it's difficult ones. But sometimes it just needs different skills. To solve it. Yeah.
Suppose you encountered a problem that was very difficult. How long would it take before you gave up on trying to solve it? What would you do? I mean, how would you approach a difficult problem?
Okay, first of all, you need to understand the problems, right? And the second thing is you have to learn, as I said, the necessary skills to solve it. Yeah, that's I think what I do to solve challenging issues. Yeah.
So you go back a step and say, well, what do I need to know in order to solve this problem? And then you get that skill, and then go back to the problem after that. And you find that it generally works for you to solve it at that point, right?
Right. So usually it's like okay, if it is a difficult question, usually that means if you use normal technique, it won't work. Because if it works, then that's not a difficult question. Yeah. But sometimes also it's you need to understand. You need to understand the question. Yeah. And sometimes the question is very difficult. It's because people had they didn't really understand the question. Okay, so that's why maybe it appears like it just didn't understand the principle of this question. Yeah.
Right. The key to solving it is understanding
Right.
the question in the first place.
Right. And then you need sometimes you will need a little bit tricky to solve your question. And so that means that you need to learn how to find the right knowledges to solve it. Yeah. So may not those knowledges may not come from what you have learned in the class. Yeah.
When you were young, what scientists inspired you the most, and why? Did you have a scientist when you were reading all those extra books? Did you come across a scientist and say, "Aha, this scientist is really my model"?
Yeah, I read a lot of books, and so I know a lot of scientists like Einstein, Newton, and also a lot of others. And sometimes it's just amazing that how come they're so smart, and they can understand a question in a different way, yeah, and how come they can solve problems which that normal people cannot see it. Yeah. So, and it's kind of like a curiosity. Yeah, and also that so I think that it's for me. I also want to like them. I also want to be able to solve those questions.
Yeah.
So that's the the drawing. I say the drawing force for me.
Mm-hmm.
Yeah, to start it.
So those great scientists made you say, "Ha, I can do that. Perhaps if I work hard and begin to look at big problems in a different way, from the normal way,
Mm-hmm.
and we might be able to come up with solutions." Right?
Yeah.
Is that a summary of what
Not
you?
really. Actually, it's the way how they solve problems.
Mm-hmm.
Yeah, because if you you're just very curious why they can think it, in a different way,
Mm-hmm.
and then you're trying to understand their theory.
Right.
Yeah.
Right.
And what is the trick? Okay, inside.
Mm-hmm.
Okay, and then you have to read books. You have to do, and then you have to study, what their theory, and that's it. Yeah.
Mm-hmm. What circumstances, when you were growing up, were the greatest risks for not obtaining your goals of being a scientist? What were the things that you encountered that were working against you, so to speak? The risk factors.
The risk. Well, if let's say, if I cannot, for example, when I take my PhD degrees,
Mm-hmm.
there is a huge risk that I may not be able to finish my PhD studies,
Mm-hmm.
because we are working on challenging issues,
Mm-hmm.
and you may not be able to solve it.
Right.
Yeah. And so that if you that means it may take you very long time to get my PhD degree, for example.
Mm-hmm.
Okay, these are the risks. Yeah, but let's say if I go to industry and right after my undergraduate studies, I can get good pay, and I can get I can find a good job.
Right.
And also the life will be much easier.
Mm-hmm.
Yeah. But,
So
yeah.
Go ahead.
Yeah. But choose a PhD degree actually is you are choosing a very hard road actually.
Mm-hmm.
Career.
So the lure
Yeah.
of a quick job making high income
Right.
was a risk factor for not going to the PhD side,
Right.
because the rewards were further away,
Right.
and the road was very difficult.
Right.
Yeah.
Right.
So how did you work your way around that obstacle? Obviously you had a chance to go get a job right away.
Uh-huh.
What made you decide to turn that down and go for the PhD?
Well, sometimes you have to stick on your faith. You have to believe that you are capable to do that. Yeah, and also, when you make the choice, for example, at the moment when I make my choice to pursue my PhD degree, I already made the decision. Yeah, so that means I know the risk. Yeah, and but
You took it anyway.
Yeah, I took it anyway, right?
Yeah.
And I'm confident that eventually I can overcome this. These problems. I can get my degree. Yeah,
Sure.
I'm confident with my capability.
Right.
Yeah, and I think that the risk is in most cases you can see in once, and then you have to make a decision.
Right.
Yeah, at the very beginning. Yeah.
You have to be decisive.
Right.
What gives you all the confidence that you have? Where did you get that from?
Well, it's the achievement you made in the past. Yeah. For example, okay, I believe I'm capable to do my PhD research It's because I did, I did quite well in my undergraduate studies and my high school studies. Yeah, so that's why I feel that I'm able to solve different questions.
Right.
Yeah, so I have this capability.
Sure.
Yeah, so I think it's the achievement you made in the past. Yeah.
What I think advice to students
Right.
is that build a track record of excellence.
Right. Correct.
That will give you all the confidence about
Right.
going to the next level
Right.
and achieving
Right.
and accomplishing
Right.
and being productive and so forth.
Right.
Because you can look back on your previous success and say, that is evidence
Right. Right.
of my ability,
Right.
and also it can be sort of the platform
Right.
on which I will build further.
Right. That's true.
Yeah.
Exactly.
Yeah,
Exactly.
that's very good advice for students, because as you build that track record,
Right.
your confidence grows
Right. That's true.
more and
Yeah.
more.
Right. Right.
So at this point, you probably think, I can do anything.
Yeah. You're right. You're right. Yeah, you're right. Yes. Yeah. Yeah.
So we'll get to that in a minute. Describe your most effective methods for studying and learning. You talked about how you need to be independent and you need to be able to learn things. What is your method? What is your technique?
Okay. First of all, I think you need to be very interested. Yeah. Also, sometimes you need to be very curious. Yeah. Because if you have no interest on anything, you definitely you want to study well. Yeah. You have to keep curiosity on everything. Yeah. And so this is number one. Number two is you have to choose. Okay, you have to see what is your weakness. Yeah, often that people may have different capabilities. Okay, but also have weakness. And if you just let's say you just focus on what you are capable, and you forget your weakness, and in many situations you may not be able to to solve a problem, because solve problem need different skills. So for my case, I spend more times on my weakness. Yeah. So this is my strategy. Yeah.
What would be an example of a weakness that a student could spend more time on and get better?
Okay, for example, I'm not good in language.
Okay.
Particularly, when I was in high school. Okay, the teaching facility is not that good. Okay, so I have to spend a lot of time to remember, all the English words. Yeah, have to spend actually, as I just mentioned, I spent almost 2 hours extra in my high school for my course studies. That 2 extra hours actually almost all,
Language.
I'll spend on languages.
Right,
Yeah.
right.
Because I know that's my weakness,
Sure.
and have to to spend extra time to improve it.
That's tough. I mean, you did this at college when you were in Tsinghua, right?
Right. Yes.
So were a lot of your classes in English, or your books, your textbooks were in English, and you had to learn from those books? Or what was the need for the language? Was everything in Chinese?
Yeah, at that time everything is in Chinese. But there are a lot of technical books it's written in English.
So you had to learn English in order to get those extra reference books.
Right.
And that gave you some help in the courses.
Right. So you have to, to read even a lot of journals. Right. They are
Yes.
they are English, and also newspapers. And if you cannot, understand English, that means you are isolated from
that knowledge.
Yeah, that knowledge. Right. Right.
So so obviously you learned it well enough to get accepted to University of Massachusetts,
Right.
and you were able to leave immediately after your bachelor's and go for the
Right.
PhD.
Right. So if I cannot, pass the English exam, I cannot go.
That's right.
I cannot
That's
go.
right.
Yeah.
So
Right.
you how should we say, you strengthen your weakness
Right. Right.
considerably, and that's a good advice for a student, to focus and get your weaknesses up to speed.
Right.
Now that's point number 2. What about the other points on your techniques, your strategy for when you take a course and you're learning new material? What was your strategy to learn that material?
And the other strategy is you have to open your mind. Sometimes maybe a question.
Have an open mind.
Yeah, have a more open mind. You.
What do you mean by that?
Well, basically you need to read books, or you have to contact the people from different areas. Because sometimes a question in this field may be very difficult, but actually if you are able to understand in a different way, you'll find actually it's very easy. So and you are able to actually connect all these things together, and then you are able to you can find that a difficult concept in this class, and once you understand it's its meanings in other areas, if you all there are similar concepts in other field which you are better on that.
Yes.
And then you find that suddenly you find this actually is you just didn't realize that you can understand in this way.
Right.
Then it become very easy for you.
Can we also your open mind concept, that's related also to the concept of thinking out of the box.
Right.
Most people
Right.
Are thinking within a certain way, but you got to think beyond that,
Right.
so to speak, and
Right.
think like you use the term, in a different way
Right.
about what it is
Right.
that you're trying to solve.
Right.
And that's a very powerful technique, you think?
Right.
Yeah.
Right.
Yeah.
Right.
Okay. Anything else?
I think that usually that's what I understand. So that's what I
Those are your techniques for being successful as a student, if you will.
Right.
What about the use of, say, notes? How do you approach that question? How important are notes, writing things down?
I think that actually for me, maybe this is not a good suggestion, but for me, and I would say that it's asking questions is more important than taking notes. And because if you ask questions, which means, first of all, means you are thinking. Second is, if you ask questions, you can remember these questions better than you just simply take notes. And in general, I think I'm not good in taking notes. I think when I was a high school student or undergraduate student, I don't take
a lot of notes.
Yeah, a lot of notes. And but I feel that if you ask a lot of questions, and you needn't read your notes.
You write the questions down.
You already understand.
You write the questions down.
Right.
Okay.
Or no, after the class.
You go to the teacher.
Yeah, you need you need to read your textbook. Okay, and you need to finish the homework. Okay, but when you read the textbook, when you are solving the homework problem, for example, you need to think about it. You need to always ask your questions. Ask questions. It's not just to read the textbook, or not just read the lecture notes. You need to ask the questions. Why it's like this? Why it's like that? Okay, if you cannot solve it, that means this is the question, and then you need to approach the lecturer, ask the reason why, to ask him to, to provide the answer for you. If you are able to understand everything, then you actually it's not need actually a very a very good nose. You already understand everything. Yeah.
What do you think would be the greatest scientific breakthroughs in science that you predict over the next 10 years, 25 years, and 50 years? You know, this could be outside of your field a little bit.
Right.
But just in general, you must have had some. You read very widely, and you think about the broad picture. What are the breakthroughs you anticipate in science?
I think we have, let's put it in this way, we have a lot of dreams, technical dreams. Well, number one, we can solve the energy issues. Yeah, for example, right now we're facing, the huge problems for energy. Yeah, if we are able, for example, to get energy out of the sun, and for example, we can, have a breakthrough in solar cells. Yeah, then we can permanently solve our energy issues. That's the first, technical dream. Yeah, and also the second would be like would be artificial technologies. Yeah. If we are able to make a robots and to take over the hard work that still requires human being to do, I would say that would be also take over those tedious work. Yeah, that can great help our society.
In other words, an advance in artificial intelligence.
Right.
Yeah.
Right.
Mm-hmm.
So I think the others actually it's becoming true. It's just the matter of the matter of time.
For example.
Yeah. For example, like telecommunication, right?
Okay.
Eventually the computer will be spread into all the field. Okay, and so everything can be done automatically, and everything we can communicate, and just like we can easily communicate. Okay, we can have the real-time communication we can have the real images. Okay, and also we can have they say the virtual, a supermarket, all these things.
Virtual supermarket,
right?
Where you have images coming and you
right.
pick the items and then they get delivered to your house.
Right, and you also the those techniques doctors can
diagnose your illness from a distance.
Yeah, from a distance. Yeah, not distance education. Those things.
You'll have some kind of sensor on your body, and then they could read it out in the hospital.
Right. I think this already is not a technique. There is no technique cycles.
Right.
It's just the matter of time.
Right.
And
there's no barrier.
There's no barrier. Yeah.
Right.
When it will spread to the entire world.
That's right.
I think this you can see actually you just cannot predict when how fast it is, but you can predict the future world, how the future world looks like. But we still have technical barriers. Okay, for example, in energy, we still have no solutions for that.
Right.
Yeah. And
Water.
Yeah, water. Correct.
We don't have solutions for the water crisis that will come if we don't develop new techniques.
Right.
Yeah.
Right. So these are the we still have a lot of technical barriers. Yeah.
So going to another level now, what do you see as the most important scientific problems that are facing the world over the next 15 years or so, and what solutions would you propose for them? What creative ideas do you have for those big problems? What are the big problems that the world faces in science?
The big problems, I would say, is energy. Energy. Yeah. And probably everything can be, it can be root to energy.
Linked to energy. In other words.
Right. For example, we have the greenhouse problems. And it's because the carbon dioxide. Okay. And it's because we burn too much petroleum, and we just didn't find a good way to get our energy. If we can find a clean energy, then we can solve this problem. And also water. I think again, if we are able to recycle our water, okay, make a good use of our water, okay, and we can solve these problems, lot of issue. But again, it requires energy.
What about food?
Food. I think in general, I would say that there is no problem for the food. Unless the population of the world population, expand dramatically in the future. With the current population, I believe the world is able to support our population.
But we still have problems of starvation in parts of the world,
it's
right?
Just because of distribution.
Distribution issue.
It's just a distribution issue. But I think I think it can solve. It's just this is more like a political issue. It's not a scientific issue. So I believe that in the future, this issue, if it should be able to solve it.
How important is education of large numbers of people in the world to solving these future problems? I mean, what is your take on education and its role?
Okay, education, of course, is very important because it will make us or the majority understand what is the problem. If you don't take education, sometimes you may think in a different way. For example, like if you don't have college, you don't go to colleges, you don't know actually what is the reason to cause the problems we face. If you have the right knowledge, then you will understand what are the policies, or what the behaviors of human beings should what are the policies we should do, and what is the best the behaviors. For example, people, they may very rich, so they think that since they are rich, they can spend, they can do whatever they want. Right. So they
not think about the environment and so on.
Right. And
but if they're educated,
if they're educated, they will understand that it's not just a matter of money.
Right.
If we exhaust the nature, the natural resources, actually eventually everybody will suffer.
That's right.
Right.
So even with all your wealth,
right,
the world would not be a pleasant place to be if all these problems are not being solved.
Right.
Yeah.
Right.
how can you connect your research with solving some of these big problems?
Okay. Yeah, I found that I'm lucky that I'm working in an area which is able to make a contributions. Yeah, I want to say that my technique eventually will play a key role on this the final solutions. But at least I'm working on a field that is able to contribute ideas or contribute a technique to a potential technique to solve these issues. For example, I'm working on a membrane center, and so membrane, you know, principally it's a good, it's alternative way, for example, to for many process. Okay, for example, you know, it can be used for what seawater desalination. Okay, it can be used to separate the hydrocarbon mixtures, and also it can help to filter wastewaters. Yeah. And in principle, if you use the membrane technology, you can save a lot of energy. Yeah. And compare it to the current method. Yeah. So, of course, this is a challenge issue. So we're still working on that, but at least, you know, we are on the right track.
Could you explain your research a little bit more detailed in a language as simple as possible for, say, a young student to understand?
Okay. Okay. My technology actually is it's a separation technology. Yeah. So it's like a membrane. It's like it's a filter. Okay. Actually, it's
A filter.
Yeah, filter. Yes. Yeah. And it's like the skin. Yeah. Your personal skin. Yeah. It's the the skin. It's help you to help your body to isolate from the outside, but it also allow, you know, your body can selectively communicate with outside.
It can allow good things in
Right.
and keep bad things out.
Right.
Yeah.
So it's a filter, and it can use to and it's also it's a simple technique to do separations. And in our world, actually, we need a lot of separations. For example, seawater we cannot drink. The reason is because it has salt. If you are able to filter the salt, then we can drink. Also, petroleum, the raw oil, have a lot of components. Okay, and so we have to separate them and into different components. For example, the petrol gas, right? And it's just you know, part of the raw oil, and we have to build refineries, big refineries. We have to spend a lot of energy to separate them, and potentially, you know, if a membrane is a filter, okay, we can filter out different components.
And it'd be less expensive than using a big refinery to do it?
Right, it's it's less you know, energy consuming. So that means also it's cheaper. Yeah. Yes.
Like, for example, now we can take water and boil it, and then we can separate the salt that way.
Right. Right.
But you were saying that we don't have to boil it. We could actually have a membrane which can separate the salt with much less energy.
Yes. Yeah.
And it'll be drinkable water.
Yeah. Right. Yeah. And also, you know, we can use membranes to fill out all bad things.
Sure.
For example, milk, you have bacteria.
Right.
You can fill out the bacteria.
Yes.
You can fill out the virus.
Well, what's the challenge? I mean, why hasn't they come up with a membrane that can filter the water cheaply at this point? Why does it take so long?
Okay, first okay, those separations are very challenging. Okay, for example, if you want to see, if you want to filter salt out of water, okay, you need a very good material. Yeah, you need a very efficient material, and so that's one. will requires a lot of research to find out, to understand. First of all, we need to understand what is the why it makes so difficult, right? Or to and then or what is the best technique? Okay, let's say they fill out of the salt.
Why are the present materials weak? I mean, what's the problem with them? Obviously, you have all kinds of substances that you've used to make membranes, and they use membranes in various capacities at the moment. But what is the weak link? Why does the material have to last a long time, or it doesn't actually filter out the things you want to filter out? Why are the present materials available not doing the job?
I think that the main issue is that we still didn't fully understand the process. For example, we have salt, we have water, okay, and we still lack the capability that how to let the water selectively pass through the membrane. But actually, our human, the nature already, they are already solved the problem, in a very efficient way. For example, in our cell, okay, we have each cell we have membranes. Okay, we have the cell actually can allow water selectively pass through the membrane. And the nature have developed specific proteins to do that.
That's right.
But we just cannot,
Copy nature.
we
Nature is very smart.
Very smart. But we are not able to do that.
That's that was actually going to be my next question. Why haven't we been able to look at a cell membrane, which is highly selective, highly efficient in keeping bad things out and letting good things in? Yet, and we can actually know the molecular structure of the cell membrane. Why can't we make an analogous membrane for all those important processes you described, like hydrocarbons and also water and so forth? Why can't we copy nature?
It's at this moment on the molecular level we still don't fully understand the interactions between the the molecules and the structures. And for example, right now we can make a membranes, okay, and it can it has good selectivities. Okay, it can allow it can filter most of the salt, and but compared to the cells, the cell membranes, particularly the proteins, we just still don't fully understand.
Don't have the efficiency.
Right. We still lack of the enough information. Okay, so how we cannot make, we just still cannot make such a membrane that can separate the water so efficiently.
I know of one researcher at KAUS who is going to be focusing on cell membranes. He's actually a mechanical engineer, and he's focusing on a biological process. So that's a natural collaboration for you to, if someone is doing work on cell membranes and they are trying to get a deeper understanding, if you work with them, you could transfer some of that knowledge to your membrane work and improve your membranes based on a better knowledge of cell membranes.
So I think that with the collaborations of different centers, okay, particularly with different discipline, we are able to understand these issues better, and then we can provide a solution for that. So
yeah, absolutely. And one of the other points about that is you, in your thesis, you were improving the performance of zeolite ZSM-5 membranes. What's that?
Okay, this is a zeolite membrane. It's a zeolite membrane, and ZSM-5 is a different zeolite. Yeah, we have many zeolites.
What is a zeolite?
Okay,
It's a
zeolite.
type of material?
Yeah, it's a porous material,
Mhm.
and it's just the structure is formed
Mhm.
and by the specific linkage, okay, between silicon and oxygen.
Okay.
So
So it's a synthetic structure.
it's not a synthetic structure. It's just formed by the nature.
Oh, nature
Yeah.
forms this. Okay.
Yeah. And
So where do you find this? I mean, it's you don't have to manufacture this.
Actually, nature will, yes, there are natural zeolites
Okay.
that exist all over the world. Actually, it's a mineral.
Okay.
Right. And of course we have to synthesize because in nature there you have a lot of impurities.
Oh, okay.
So in laboratory we synthesized by ourselves, but it actually formed. It can form naturally.
Mm-hmm.
Okay. So here the beauty of this material is it has a very regular pore structure. Yeah, because it formed by the material itself. Okay, so the pore size is very uniform. Okay, and when since it's a porous material, also the pore size is in the molecular level, and therefore you can use it to separate molecules, different molecules. Okay, and the basic idea is you can use it as a seed. Okay, if you have two molecules A and B, if let's say molecule A is bigger than the pore, okay, it cannot pass through. Okay, if molecule B less than the pore, then it can pass through. Then you can use this zeolite membrane to separate
those two.
Right.
Mm-hmm.
So we have different membrane materials like polymers.
Are those pore sizes variable? Are they all standard sizes?
For different zeolite, they have different pore
sizes.
Yes.
So you can change the type of zeolite
Yes.
to separate different components.
Yeah. Yes, correct.
Mm-hmm.
Yes. Yeah.
Is that our best prospect
Mm-hmm.
for how should we say, a gold standard membrane? You know, if we look to the future as to our ideal membrane for all these big processes you described, water desalinization and so on, is that the best potential material that we have to do that?
In terms of the structure, yes. Yeah. And but of course, this material they also have a lot of disadvantages. Yeah.
What are the disadvantages?
The disadvantage because it's an inorganic material, so it's very brittle.
Brittle.
Yeah, brittle. So it's difficult to use.
Longevity.
Yeah.
It doesn't last long.
No, it lasts long. It lasts long. It's just very brittle, so it's difficult to handle.
Oh, okay.
Yeah. And you need to be very careful. And second is the productivity is low. Yeah. And so the other material is like polymer membranes. Polymer you can easily make in large scale, and you can produce very fast.
And it's not brittle.
Yeah, it's not brittle. Yes, easy to use.
This is organic.
Yeah, but the problem is for polymer, the pore structure is not uniform. So the selectivity is not good.
Sure.
Yeah, but this material, the pore size is very uniform.
Sure.
Yeah, and it's rigid.
That's right.
And also
stable.
Yeah, it's stable. Yes, and also it's because it's inorganic, which means it's strong. It can last long. Yeah.
That's right.
Yeah. So in terms of the structure, yes, it is a very good material. Yeah.
So what improvement did you make in it in your work? And are you still working with this material?
Yes. Yes.
What improvements have you made? What is the impact you've had on this material?
Yeah. So my contribution is I think it's in two directions. One is that we are able to orientate the pore. Okay, so these are those materials that have a 3D pore structure. Okay, and so which means they are anisotropic. Okay, and so the pore, for example, the pore, they are facing in one directions. Okay, if the direction is not, if the orientation is not correct, then those pores may not be accessible. Yeah, or it may have a higher resistance. Okay, so we developed a technology that we are able to orientate those pores. Yeah, so for example, for all the pores can vertically or perpendicular to the substrate. Hence that the material can pass through the membrane with less resistance.
All right.
Yeah. So which means you are able to get higher permeability.
Right.
Yeah.
And it takes less energy to push
Right.
the liquid through.
Right. Right.
Because it's a
Right.
straight orientation rather than
Right. Zigzag.
zigzag.
Tortuous channels.
Right.
And so this is the first. The second is the membrane made in the in other studies. It's usually they have defects. Yeah, and as I said, those materials are very brittle, so they can easily crack.
Right.
Yeah, and because they are crystal materials, so usually you will have a green boundaries between those crystals. Yeah. So if the green boundary is not tight enough, it actually forms a defects. Yeah. So again, we developed a technology which we are able to control the green boundary structure. Yeah. We are able to control the growth of these crystals so that they can they can grow very tight, so they can seal the green boundaries. Yeah. So that's why our membrane, the membrane we made, have very good performance. Yeah. We by oriented the membrane, oriented the pores, we are able to improve the permeability. Right. And by reducing defects, we are able to increase the selectivity. Yeah. So we are able to achieve high permeable and high selective membranes. Right. Yeah. But in the previous studies, and the people either they can either you increase the you have to compromise. Yeah. Either you increase the selectivity, you reduce the permeability, or you increase the permeability, you have to sacrifice the selectivity. Yeah. And because I think we are able to understand the structure of the membrane, so we are able to achieve the increase both. Yeah.
So what I'm hearing is that you need a structure that is very, very stable and reliable. Right. Because if you have it in a critical situation, say for example water, right, and it lets a toxin in, right, or salt in, right, because it becomes defective in the process of functioning, then you had a big problem, right, with your system. Right. So you really got to have good reliability and longevity and so on, right, in its function. Right. Yeah. Right. Right. And that's a big challenge right, to develop that type of membrane. Right. That's true. Yeah. Yeah. So when do you predict that you will have a breakthrough to make that gold standard membrane that the world is waiting for?
At this moment, we are still need develop a pilot scale setup to demonstrate that those type of membranes, they are good, but also they are economic. Yeah. So
what kind of scale?
Pilot scale. Which means it's a scale between the laboratory and the industries. Yeah.
Oh, okay, right. Okay. So spell that word.
Okay. Pilot, Pilot.
Oh, pilot,
Yeah.
pilot. Oh, now I understand. Pilot scale.
Yeah.
That could be used industrially.
Yes, right.
We can, if we do it in the lab, that doesn't mean that it'll work industrially.
Right.
We gotta move it,
Right,
we gotta, what to say, is it scalable?
right. It's scalable
Mhm.
and economic.
Mm-hmm.
So that's I think the is the future my future plan.
Mm-hmm.
Yeah, in cost, we want to demonstrate a unit that to show that okay, this type of material, these membranes, they are you know they just not just capable to do the separation. They are also economic.
Yes.
The process is economic.
What is that, 5 years?
Hope so. Yeah. Of course I wish it can happen as soon as possible.
As soon as possible, right.
Yes. Yeah.
Okay, moving right along, we are coming close to the end here.
Okay.
What would this breakthrough mean for Saudi Arabia?
Okay. If we are able to to make a good membrane, okay, particularly if we are able to demonstrate a unit, a separation unit, that I think will benefit Saudi Arabia a lot. First of all, we can, for example, the membrane I developed is particularly useful in petroleum industry. Yeah, and we can use to separate those chemical compounds. For example, petroleum, the
Various components.
Yeah,
of
the
course.
different components. Yeah, in petroleum industry, and with much much economic way, then definitely it will. Since Saudi Arabia is it's an oil country, so that will definitely help to reduce a lot of cost. Yeah, and also we are seeking to make good membranes for like water desalination. Yeah, these are very useful for Saudi Arabia, and also those membranes they have potential application in wastewater treatment. Okay, and again, this water and this is a big problem, not just in Saudi Arabia, also in almost all countries. Yeah, so we want to demonstrate. We have two targets. One is we want to develop new membrane materials, which is able to achieve all these tasks.
Mhm.
Okay, which is able to solve these problems.
Mhm.
Okay, but from the other hand, we also want to demonstrate that those processes are economic.
Mhm.
Yeah, compared to the current method.
Mhm.
Yeah, that's our research.
So the Membrane Research Center at KAUS has an enormous potential for benefiting Saudi Arabia in two ways that we know for sure, but possibly many other ways because of the broad application of quality membranes in various areas of science and in industry.
Right.
What advice would you give to those young scientists who may be listening to you now on if they want to pursue your particular specialty and career in chemical engineering and in more specifically in membrane research?
My suggestion, first you need to be very interesting in this area. Yeah, so you need in general you need to be very interested in research. Yeah, you need to be aware that this would be a tough research area, and you are willing to take this challenge. Yeah, and so I think that's the
Well, I guess one of the things is they would first have to know about this area because membranes is not necessarily on the top of everybody's list
Right.
as being an important area.
Right.
So, what advice would you give to them to find out about membranes? I'm talking early on,
Right.
not so much after they get to their PhD program, but
Right.
how can they find out in high school, in junior high school, about your area, and what do you recommend they do early? Because you think about people who become really world class in something like a sport or in music. They start at an early age and they start preparing and they start practicing. Do you have a similar idea for a young student out there?
Okay, I think a membrane actually exists everywhere. Actually, if you take even a filter paper, right, you filter sand out of water, it's a membrane. It's a membrane process. Yeah, so membrane actually is not like a very fancy or very very hard concept or very difficult like process. It's actually we use every day. Yeah, probably just didn't realize this is a membrane process, or probably you just didn't realize that you can control this process. Yeah, or only if you are curious about the process, then you will start to understand this process.
Right.
Yeah. Otherwise, we are actually doing it every day. You just didn't realize.
The face mask that people use in a hospital
Right.
to protect against germs
Right.
is another example.
Right. Right. Yeah.
And like you say, the skin.
Yeah.
We have
Right.
every cell.
Right. Every cell.
So many examples.
Right.
Yeah.
Right. And the second thing is probably you just didn't realize the capability of this membrane process. You probably didn't realize that use a membrane process we can actually use it for large industry processes. And most important thing that you probably didn't realize that those processes has potential to replace the current technologies. For example, they are largely exist in the industry, like the refinery,
Expensive processes.
Right. And
distillation.
Right, distillation, correct.
For desalinization.
Right. So I think the membrane process is not a difficult process. It's just the problem is you just need to realize the capability of this process.
We stand on the shoulders of giants in science.
Right.
That is, we benefit from what the previous scientists have done to build the science to the level in which we expand it further. Who are the pioneer researchers in your field, and what was the breakthrough that they came up with as you go back in the history of membrane research?
I think the first breakthrough happens in 1960s. Yeah, I forgot the name, and they actually for the first time, I think actually that one is for polymer membranes, and for the first time they are able to demonstrate that the membrane process is the productivity is compatible or is competitive with the current technology. Yeah. So before, usually membrane process is a slow process. Yeah. People make thick membranes. Or for example, if you use people use the sand to fill the water to get rid of dirties. So you need they use a thick membrane. So the permeability is very low. Yeah. I think that the first breakthrough happens in 1960s for the polymeric membranes.
Which are relatively thin.
Right. They are able to make what is called asymmetric membranes. Right. So the permeability is fast. At least people see the future that this process is capable to compete with other technologies. Yeah, and then so this is the first breakthrough, and then the the second is I think is it happens in the water desalination, and I think until 1990s, and membrane process actually they the only very few cases large scale application of membrane process, and because membrane still face a lot of problems, for example besides the permeability problems, also they have fouling problems, the stability, and also the cost of the membrane. So I think after 1990s, okay, then the membrane, I think of course there are a lot of factors, membrane materials and designs, all these issues make the membrane the process is can compete with other method in the water desalination. So slowly membrane process it replace the conventional method like a thermal process in the water treatment, particularly with the cost of the membrane reduced, and also we have more experience with the membrane process, the process, and also and the quality or the efficiency of the membrane become better, and right now it's the membrane process now is become the majority in the water desalination process. So this is the second breakthrough, which means that okay, membrane process is able to use in large scale. And then so now we, because of this example, okay, so which means okay, membrane is able to use in other industry processes.
So that's reverse osmosis.
Right.
Is that how they?
Right.
One of the breakthroughs was led to
Right.
using that technique. Eh?
Right. Right.
What is reverse osmosis?
Reverse osmosis is okay. Usually they say if you have salt water, and if you contact it with pure water, right? So the pure water will penetrate. Okay, will goes to the salt water. Okay, because the concentration of the salt. It's
Gradient.
higher.
It's a gradient.
Right. Correct. Is the concentration gradient correct? So the pure water will goes to the salt water. Okay, but if you apply a pressure on the salt water side, you can actually press the water from the salt water to the pure water. This we call the reverse osmosis process. So in seawater desalination, we have the seawater, we have salt inside. So if you apply pressure on the seawater, then you are able to create pure water. But you need a membrane which selectively allow water passing through your membrane. Otherwise, everything pass. If everything passes through, then you cannot get pure water. So you need a barrier.
What would you consider the greatest achievement that you've made so far in your profession?
The greatest achievement, well, I think I still needed to achieve. I wouldn't call it it's a great achievement. It just by working on this area, on this zeolite membrane area, we are able to understand the membrane, the properties. Okay, for example, the structure of the membrane with the performance of the membrane. Okay, And well, for the performance of membrane, usually we say is the permeability and the selectivity.
Correct.
Yeah. And so we are able to better understand the relationship between the membrane structure and the performance. Okay. So for example, to get better performance, what are the structures we are looking for? Yeah. So this is I would say number one. It's the understanding of this process. The second is we are able to develop a technique which we are able to control the membrane structure so that we can achieve good performance. Yeah. So that's what we achieved in the past. Yeah. So in the future we still face a lot of problems. For example, for new separations. Okay. And
What type of separation?
for loop separation, for example, for the
LOOP?
no, sorry. I say for loop, for other separations.
Other.
Yeah.
New.
Yeah, new. Yeah.
New
Yeah.
separation. Oh,
Right.
okay,
Yeah.
okay.
For loop separation, for example, say separate air. Yeah. Or other example is seawater desalination. Right. We still need understand those process and also we also need to develop new materials, which is capable to separate those systems, those important systems. Although even though for some systems we understand how to, what is the structures we should develop to separate them, but how to achieve this structure, we still need a lot of work.
You have a recent paper on the synthesis of MOF membranes, metal organic frameworks. Explain that.
Okay, metal organic framework is a new material. It's the difference between those materials with zeolite membranes. Zeolite material is zeolite is a pure inorganic material. Yeah, but metal organic framework material, they have inorganic component. Also, they have organic component. Yeah. So because of this, because of the inorganic, because it's a hybrid material. So that means the structure usually is stronger than the organic materials like polymer. Yeah. And but also because it has organic components, so the structure is flexible than zeolite structures. Yeah. And we believe that this kind of flexibility in the structure can help to solve some separation challenges. Yeah. Because some separations you will need it's not just the pore structure, it also need a suitable interactions between the structure and the molecule. Yeah. So this material, they provide us a solution that we can or provide us a flexibility that we can we can use those material to separate.
So we can
challenge separation system. Yeah.
Can we suggest that this is instead of being a passive structure, it's a structure which is passive as well as functional.
Right, correct.
It contributes.
Yes. Right.
The material itself contributes to the process, along with being a structure with a pore that will let the material go through.
Right. Right. So so that's why we work on this material and we are interested to make it as a film, and so we believe that this film give us potential to be able to solve challenge the separation systems. Yeah.
So what are the future goals in your career? We're coming close to the end now with the questions. What would you say are your future goals?
My future goals is in general, we want to contribute. We wanted to develop, to develop like a efficient membrane process, okay, which can be used to solve the current challenges. Okay, for example, we wish we can develop membranes can use to separate hydrocarbon mixtures, to separate water, seawater. We can separate say air. Yeah, we can
What's the last one?
air.
Air?
Yeah.
The atmosphere.
Yeah, atmosphere. Right.
So what do you mean separate the atmosphere? What do you mean?
Separate the oxygen and nitrogen.
Uh-huh.
Yeah, because we in a lot of situations we need pure oxygen. For
All
example.
right.
Yeah. And but of course these are the particular so specific targets.
Mm-hmm.
Okay, but to solve these issues, we need to understand the fundamental principles for that can apply to any membrane process.
Mm-hmm.
Okay, for example, it will involve material science. Okay, we need to understand the mechanisms that membrane to separate different materials. Okay, therefore that from the material side we can develop a suitable material for that particular challenge.
Mm-hmm.
Yeah, and also we need to develop the process design. Yeah, and so that the membrane process can be scaled up, can be used at a large scale, and in large scale, and we can, for example, we can use it as an alternative method.
Mm-hmm. In the industrial
in industrial
scale.
Yeah, industrial scale. Yeah.
Mm-hmm.
So that's
Mm-hmm.
our future
Mm-hmm.
plan.
Cool.
Yes.
Describe a typical working day in your profession. By the time you reach your office and you begin your day, what is it? What do you do throughout the day?
Well, I don't have a regular schedule. Yeah,
Mm-hmm.
but usually.
No, I'm not saying so much at Kaus we're just beginning,
Right.
but I'm saying if you look back over the last couple of years
Uh-huh.
and you sort of average out a day. Every day is different, of course, but
Right.
what would be the typical things you would do on an average day?
Okay, I think each day what we need to do is first we need to read literatures.
Literature.
Yeah,
Mhm.
literature, and we need to spend time on lab. On the lab.
In the lab.
Yeah, in the lab
Uh,
to work on to do the research.
so what is that like when you're in the lab? What do you do?
We do synthesis. Yeah, we do the testing, and we also do characterization. Yeah, so synthesis is used to make materials, and testing is to see how good is the material, and characterization is to, if let's say you get this performance, you need to understand why you get this kind of results. Yeah. So that's the three components for our experiments. Yeah. And also the other thing you need to do is a discussion. Yeah, you need this discussion or interaction with the peoples. Yeah, you need either discuss the problems you face, or you attend the seminars, or you just chat with other researchers, and sometimes you may get good ideas, just among those talks.
Sure.
Yeah.
Would that be with your colleagues or your students, your postdocs, all of the above?
Yeah, actually all above. Yeah, sometimes
You'd have planned meetings, or these are just random conversations?
You can have, of course, we will have planned meetings. Yeah. Also, just sometimes they just some very free like talks.
Mm-hmm.
Yeah.
Mm-hmm.
So yeah.
And what else during the day?
Yeah, I think that's would be that's in terms of the scientific activities, that's would be.
You obviously have to teach some classes.
Yeah, oh yeah, sure.
occasionally.
Teaching classes. Yeah,
Sure.
yeah, that's my teaching duty. Yeah, yeah.
Don't forget that, right?
Yeah,
That's right.
Yeah. Also, we need have coffee. Yeah.
Sure,
Yeah.
sure.
But we then when you have a coffee with somebody, you
Yeah,
can talk.
you're actually conducting business,
Right.
or coming up with a new idea, right?
Yeah.
And the way Kaus is designed, you'll notice there's so many places where they have huddle rooms. They'll have little tables with 3 or 4 chairs around it,
Right.
and they'll have these cafes along Discovery Walk,
Right.
and so they have many opportunities for people to sit down
Right.
and have a good discussion.
Right.
Yeah,
Right.
yeah.
Right.
It's
That's actually what I like it. Yeah.
yes, yes.
And the university is not it shouldn't be a very serious place. Yeah, it should be a very
Fun place.
Yeah, fun place.
Like Google,
Yeah, right.
like the Google campus where everybody moves around on rollerblades,
Right.
and so
Right.
forth,
Right.
and play practical jokes on each other.
Right.
You can come up with a new idea by playing a practical joke. Right?
Yeah, that's true. Yeah, right. Yeah, you needn't necessarily that you always stay in the lab.
That's right. That's
Yeah.
right.
That's why actually at the very beginning I said hard work is it won't necessarily lead you to success. Yeah.
That's right. Well, that's a good lead to the next question, and we're getting toward the end here. What is your definition and your secrets of success?
Secrets of success. A secret success, I would say, is you have a clean target. Yeah.
A clear target.
Yeah, clear target. Yeah.
Mm-hmm.
So you know what you're doing, and so you always be consistent. On that.
Moving towards your target.
Right, moving target. So that's what I would consider sequence success.
Mm-hmm.
Yeah, so you know that you get this success, but you know that this is not the end. You are still facing more problems, and you need to add the success, and you know how to do that, and then so then and until you reach your target.
And so your definition is knowing the target.
Right. Yeah. So
So that
you know
so that actually
Right.
precedes actually accomplishing your goal.
Right.
So
Right.
so you're saying that even before you start, you can be successful, because if you know your target, you'll have a great chance of reaching it. Perhaps, is that what you mean?
Yeah. You at least you need to know what you are doing.
Okay.
Yeah.
Okay.
Yeah. So you know that this is the direction what I'm going to do.
Okay.
Yeah.
So now, although it may take you 10 years
Yeah.
to get to that target,
Yeah.
you're defining the success before you start.
Right. Well, it's not defined as a success, but you know that you get this success. You know what is the next one waiting for you.
Mm-hmm.
Yeah, and sometimes maybe you will get successful just by lucky. Yeah. Then you probably you won't know what you should go next.
Yeah.
Yeah, but if you know the direction, you know that after you get this success, you know what the next one you need to approach.
Mm-hmm.
Yeah.
What are your hobbies? In order, when we think about the balance in our lives between our profession and our life in general, what hobbies do you pursue?
I like traveling.
Mm-hmm.
And also I like it to experience different cultures.
Uh-huh.
Yeah, that's also one of the reasons why I came to Saudi Arabia,
Yeah.
because in my whole life, I never thought about actually, the I actually although we have Muslim society in China,
Sure.
but the culture it's still it's similar.
Mm-hmm.
Okay, and I think coming to coast it's also a very good challenge, good opportunity for me actually to experience. It's a quite different culture, from my home country.
Mm-hmm.
Yeah, so I think actually even just the last week we came here. These few days we already see many interesting things.
And
Yeah.
so many different people.
Right, so many different people. Yeah, and particularly the culture here.
Sure,
Yeah, it's you can see actually the behaviors. Even the rules all are different.
Sure.
Yeah.
Sure.
And these are very interesting.
Mm-hmm.
Yeah, very interesting.
Mm-hmm. And so, how large is your family?
Oh, I have two daughters,
Mm-hmm.
and and
How old are they?
one is 7, the other one is 5.
So they're coming at an opportune time to begin the education in Kaus,
Yeah, right.
the Kaus schools.
Yeah,
Right?
yeah,
That's fantastic.
right.
And is your wife? She's working, or she will be taking care of the daughters.
At this moment, she will take care of the kids.
Mm-hmm.
Yeah, but in the future, she might find a part-time job. Yeah.
And what is her profession?
Her profession, she like cooking.
Oh, I see.
Yeah. And she like to make friends. Yeah.
Okay.
Yeah, and actually, we actually live. Originally, I worked in Nanotechnology University.
Yes, in Singapore.
Yeah, and my wife, she participated in a lot of activities.
Mm-hmm.
Yeah,
Mm-hmm.
and so she liked to make friends with.
Well, if she likes to cook, she'll have a lot of people here who want to take a class from her, so she can teach how to teach Chinese cooking.
Yeah.
That's a popular form of cuisine in Saudi Arabia,
Yeah.
and many people want to learn how to prepare that. So
Right.
she has a lot of waiting students for her.
I hope she will find
And she'll make a lot of friends that way too.
right. She will make a lot of friends, and
Yeah.
she will enjoy life here.
That's
I
right.
agree with that. Yeah.
Absolutely.
Yeah.
Professor Zhiping Lai, thank you very much for a very comprehensive and detailed interview.